As Dan said, I'm Mike with Adhesives. I think I know what button to push. I'm going to talk about wearables and specifically stick-to-skin wearables. And let's get started. I'll give you a little bit of a rundown on Adhesives first. Won't be a commercial. I'll just tell you a little bit about us so you can have some context to the conversation I'm going to have throughout the presentation. So we're a contract manufacturer. We have 60 years of manufacturing experience. We've got about 100,000 plus square feet in our 3-building campus in St. Paul, Minnesota. We have hundreds of customers ranging from startups to 17 of the largest medical device companies in the world, organizations in the world. We focus 100% on medical device manufacturing, and we're a converter of flexible materials. I'll talk about some of those materials in a little bit. You can also see those materials on our table next door. We offer design for manufacturability. We help with material selections. We assist with material testing when necessary as well. We can assist in developing prototypes, and then we can take those prototype designs all the way into commercial volumes and high volume manufacturing. Our facility includes ISO Class 7 and Class 8 clean rooms, and we have capabilities from rotary converting to laser converting, die cutting, sheet converting, laminating. We do placement of electronics and robotics in line, and all the way through to packaging. We are ISO 13485, ISO 9001 GMP, and we are a manufacturer of record for close to 30 family of products with the FDA. So we're the manufacturer of record registered with those products. And something I think Mark Rutkevich, our VP of Quality, is going to talk about a little later, is that we led the way with the FDA quality maturity model, and that was exciting for us, and it's done some great things for us, but I won't steal Mark's thunder. I'll let him talk to that. And Adhesives is also a 3M preferred converter. So there's all kinds of wearables out there, from medical and athletic monitoring to drug delivery. What I'm going to talk about is the medical stick-to-skin kinds of wearables, and specifically I want to talk to components like you see on the slide here, the adhesives, the coated products, the coated tapes, shielding tapes, and protective layers. We're not electricians, we don't do injection molding, so I'm not going to talk to those pieces of the puzzle as you see it there on the screen. But we have partners that can help us get those components done for people making wearables and medical devices, and then we would bring them in to handle that and deliver a full solution to you. Okay, so why might you want to stick something to the skin, I guess, is a good question to ask, so we thought we'd spend a little bit of time on that. Depending on where you're going to put the device on the body, stick-to-skin might be the only solution for you. Sometimes it's the best solution to gather information that you need to gather and or deliver medication. The weight of the technology is sometimes something we want to consider when sticking to the skin. And also, certainly, most people, or some people, depending on the ailment, would want a discrete solution. So you would, they wouldn't want to display the device, so you'd want a discrete solution. And they certainly may want to, get their ailment and or their condition known, so you'd want it discrete. If the device is a one-time use device, sometimes that lends itself well to a stick-to-skin and disposable solution. However, there's opportunities unlike the example I showed where you'd have a technology created and a reusable patch, and that's certainly an option as well. So you would have a reusable patch and reclaim the technology, recharge the technology. Also, when sticking to the skin, you may need that consistent contact between the device and the body to get the job done that you're looking for. Example might be a collection of fluid or precision monitoring, and in some cases, as I mentioned earlier, drug delivery. And attaching to the skin is often a good option when you're dealing with multiple size users. So kind of a one size fits many approach. So on the material selection side, when we start to talk about what materials we're going to select, we want to talk about the most common skin type is something that you'll need to take into consideration. Is it an infant? Is it an elderly person? And so forth. We'll also want to talk about the time, the length of wear, I guess, is the really critical item. How long is it going to be on the skin? Design specification, we want to know if that's locked or if you're open to alternative materials. Sometimes that's a good idea at the prototype stage to make sure that we're open to the alternative materials. And we also need to talk about, you need to start considering what conditions those materials are going to be exposed to beyond being stuck to the skin. Is the person going to be a swimmer and so forth? We need to understand those things. We also need to define the contact area to the skin. So how much skin is going to be covered? It's critical to know that when we're talking about stacking up these materials on the body. We need to talk about conformability requirements as well as ease of removal kinds of things. And whenever we're covering skin or sticking something to the skin, we need to talk about your expectations or the expectations of managing moisture and perspiration. What are we going to do there? Are we looking for moisture transmission and evaporation, or are we looking for the materials to absorb the moisture that we're going to deal with? And we'll need to work through how those materials and those combination and stack up of materials work to accomplish that goal. In most cases, we oftentimes have to adhere to the device as well, especially if it's a disposable patch. So we'll have to talk to the topic of how do we adhere to the device itself? What is the device made of? And how much contact space do we have to the device itself to adhere to it? And again, when you're talking about materials, it's always a good time to be thinking about the packaging requirements as well as the sterilization method you're going to use for the product. So I'll touch just briefly on the kinds of adhesives and or categories of adhesives, if you will. There's exceptions to what I'm going to say, but in general, silicone is used for delicate skin, elderly, infants, and so forth. The acrylics are a solid solution for the longer term wear and have excellent processability characteristics. The silicone rubber is a proven device side adhesive and has the ability to stick to low surface energy materials. And the hydrogels are used occasionally. They have some good features as far as low trauma removal and high conformability. I think you would use those often if the device itself has to be in the same exact location on the body all the time. So that would be an occasion to maybe use a hydrogel. Okay, so we've talked a little bit about wearables. We talked about considerations of why you'd stick something to the skin, the material characteristics or considerations, as well as some adhesive options. I'm going to jump into talking about the process to actually manufacture the part and or the device and how we do that for manufacturability. It's important to consider, how these pieces are going together and how the materials are going together as we as we do it, as we decide the process and design the process. And because those materials rarely have the same characteristics as each other. So like stretch, for example, there would be some significant differences, in the process to put those components together is important to consider early. So the manufacturing process and design for manufacturability, I think we'd want to start talking about things like, is the design static, or is there a family of similar parts? Is there a need for ongoing customization? Just, you know, as we think through that, inline rotary converting and laminating lend itself well to low mix, high volume production. The automation and robotics and flexible work cell development lend itself well to a higher mix, lower volume production, batch quantities. We like to talk about the estimated timeline from prototypes to commercial volumes. That helps us figure out where to put our resources, and helps you, I think, figure out where to put your resources. And then, we need to start to talk about the tooling required to build the devices, and laser, flatbed converting, rotary converting, all of those options have different costs associated with them. But it's also important to think those through, because not only with the process, but the tooling design has significant impact on material utilization, and that would be an ongoing cost to you if you make that misstep early. And we would all like to avoid that. I'll spend a minute talking about inspection and quality. It's important to start thinking about how the device will be inspected, and the quality requirements as you are going through the process of making the part, and also even the manufacturing equipment. How is that going to be qualified if it's new equipment? Where is the material traceability requirements? What are the material traceability requirements should be thought through? And what process controls are required as you start to build the part? In change control, for example. The goal is to build a robust and reliable process, not only at the prototype stage, but through manufacturing and high volume production. So what is always a conversation in every project I've been involved with is, I would say, performance measurements and critical to performance tolerances, as opposed to measurements and tolerances, because we need to wind down and find out which ones are absolutely critical for performance of the device. And I would urge you to give yourself room where possible in those measurements and tolerances, and what that will lead to is a much more robust solution at the end of the day when you start to do high volumes. And then, what you can do in prototyping at jigs and pin guides and things like that may be a little bit more challenging when you start to go inline full volume production. And when we talk about inspection, like our gal on the slide there, doing it offline is certainly an acceptable way to do it. While she's doing that, presses are usually stopped. We're waiting to get her confirmation. So again, what we try to do is we design that quality process is to try to bring it as close to the manufacturing process as possible, so that we are inspecting ideally in line, but in some cases as close to manufacturing as possible, so that we are producing parts at volume. And those investments for that inline inspection can often pay for themselves very easily and very quickly. That's my time. That's all I got. Thanks.